Here we go. So exponent laws, part 2. Do you have that title down? Oh, I didn't even have it on the screen. There it is. There's the title. Exponent laws, part 2. Welcome. Don't forget to pick out an orange shirt tonight. Track down something orange to wear on Wednesday. Exponent laws, part 2. Here's the last of the 5 laws we have. Law 5, power of a power. And the idea is, what happens if, instead of there being 2 things multiplied, what happens if it's an exponent on an exponent? And this one's the one weird one. This one isn't quite so easy to just look at and say, I totally get it. All right, so if this one's a little more difficult, it's totally like that. And it really rolls into some very difficult questions. I'll do some of them, but there's a reason there's so much practice here, is because it takes a while to be able to juggle all these things. So if I were to write this out, 3 to the power 2 to the power of 4, and again, I know about BEDMAS. I know you could just go 3 squared, which is 9, do 9 to the power of 4. If you're given all the numbers, you really don't need exponent laws. They're just tidying things up. We're getting ready for variables. So we'll do it with numbers and come up with a nice law. If it was 3 squared to the power of 4, it would be 3 squared times 3 squared times 3 squared times 3 squared. Oh, it's way worse than that. 3 times 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 3. How many 3's is there? And I'm going to ask the person who answers, did you count them? Or was there something about the situation that told you how many 3's were coming? How many 3's is there? Did you count them? No, you knew how many there was going to be. How many is there? You said 8, but how did you know how many there was going to be? Just multiply the 2 and the 4. And that just really makes sense here, is how many groups of 2 do we have? We have 4 of these groups of 2 3's. So it still fits with what we know about multiplication, 4 groups of 2. And you get 3 to the power 8. We get this beautiful law, which is that if you've got x to the power a to the power b, if you've got 2 different numbers out there, you can just multiply the 2 together. You don't even have to worry about same base here, because there's only one base. If that's confusing at all, here, check out this example. 4 to the power 3 to the power 5. What do you do with those 2 exponents right there? You just multiply them. It's power of a power. So you get 4 to the power 15. And I believe if you put 4 to the power 15 in your calculator, you can do it in yours too. Let's go 4 to the power of 15. This is the one I really wanted to show off and show. When I do 4 to the power of 15, I get 1073741824. Maybe some of your calculators even go to scientific notation. Can we agree that's too big to be writing around? I don't know where the line is. I'm not going to draw a line. I'm just going to say when they get really big like that, just leave them as 4 to the power of 15. That's the better way to write them when they get to be that big. X to the power, well, this is what we were getting ready for, variables. X to the power 4 to the power 8. Now what happens when you've got exponent to an exponent? You multiply the 2 exponents, and 4 times 8 is 32. Negative 3 to the power 2 to the power 7. Power of a power. Multiply those together, you get 14. Now you might have seen part of the difficulty of keeping track of all these exponent laws. When there was only one exponent law, it was so easy. When there was 2, not so bad. 3 and 4, well, okay, maybe it was still pretty good. But by the time you put this 5th law on, it's like a bit of a house of cards, and some practice is needed. But do you have any questions about this 5th law, or 5th power law? It's good? I heard somebody out loud say they were almost done page 96. Or a lot of, well, give yourself a number 1 to 5. 5 being 89's virtually done. How many people are virtually done 89? Maybe you have a couple questions to work on. Okay, page 96, how many people have worked ahead? Give yourself like a 3 if you've even started it. 5, like 96 is almost done. Oh, so some people have worked ahead. Okay, that's fine. If you haven't worked ahead, that's all you're finding out that people work through it fairly quickly, so it shouldn't take you forever. But again, if there's questions you get stuck on, do not panic about those. Come back and ask me tomorrow. Don't freak out and go, oh, I couldn't get this one to work out. If you watch the grade 12s, I at one point was going to record them asking me questions, and you'll see how good they are at. These are the 12 AP kids. Like, these are the guys, the ones heading off to university next year, and they ask me constant questions. They're right on me all the time with questions. So don't feel like that's a bad thing. It's a good thing. Okay, combining the laws, I have 5 examples just like I did before. I've got them on a separate sheet here. I want to use all the laws together. And like I said, I'm going to try and do this reasonably quickly, but stop me as soon as I do something too fast, okay? This one, 3 to the exponent 4 to the exponent 2, 3 to the 7 to the 3, 3 to the 5 to the 3, 3 to the 3 to the 4, okay. This last log law, weirdly, is if it's there, you probably want to do it first, right? Because it's not easy to add these things together right now because they're not individual powers. They've all got power of a power on there. So if there is power of a power out there, you probably want to do it first. And so here, 4 times 2 is 8. 7 times 3 is 21. 3 times 5 is 15. And 3 times 4 is 12. We just look at that really quickly to make sure I did that right. 8, 21, 15, 12. Okay? So if you know power of a power is coming, you're just multiplying those two exponents. Any problems there? We good? Seen some nodding? If you're good with that, the rest of it is just the previous lessons. Yeah, that's the only thing new there. On the top, it's multiply. When you multiply, what do you do with the exponents? Add. Hopefully that's becoming entrenched now. So I add those two. And on the bottom, the same thing. Multiply, you add the exponents. And now when I divide, what do I do with the exponents? Subtract. So now I get 3 squared is 9. Now, listen. It is possible that if you didn't see this in grade 8, that now it seems like I'm going really fast. You're like, oh my, I can't keep up with this. I don't know how he's getting all the laws all together. I need to tell you that with a little practice, it's not much of a problem really. So if you're having trouble, just keep practicing them. Re-look over the video. The nice thing about the video online is you can slow it down, go step by step, and it's really not, don't feel intimidated by this stuff. It's not the worst stuff ever. Any questions about that? This time I did go to 9, because when I went 3 squared, that's a pretty reasonable number, so I'm going to get that as a number at the end. More time on that one? Who needs more time? It's good. This question can be done 2 different ways, actually. So maybe you want to wait to copy. Maybe you want to see me do it both ways, and then look at it and decide, yeah, that's the way I'd think about it. I like it that way. I just said if there's power of a power out there, you should do it first. Well, I didn't say you should do it first. I was trying to be careful. You should usually do it first. In this question, power of a power means I got power of 4 on both of these powers. Because we said, if there's an exponent 4 on the outside, it gets applied to everything. So this gets multiplied by the 19. The 4 gets multiplied by the 19, but also by the 15. So I'd get 2 to the, oh, here we go, big number here. 4 times 19. 4 times 10 is 40. 4 times 9 is 36. I think we've got a 76 there. 4 times 15, that's not so bad. 4 times 10 is 10. 4 times 5 is 20. I get a 60 there. And so when it's all done, I get 2 to the power of 16, which you can put that in your calculator, but I think you'll find out it's a really big number. I don't want to have to go to that. I'm going to put it in mine, 2 to the power of 16. Oh, 65536. Tough decision. And I wouldn't mark it right or wrong based on what decision you make here. I would say 65536 is sort of on the edge. You know, maybe it's better to write as 2 to the power of 16, but if you write 65536, that's okay. Can anyone see another way I could have done this? Yeah, and see, now we're released from the rules of bedmass in the middle of this. It's like bedmass, and now we've added exponents laws 1, 2, 3, 4, 5 as options here. And they're not really lower than bedmass, they're just choices here. But she says, I think to me it would make more sense to go after the inside of the brackets if I can, and you can here. 19 minus 15 is 4. And then what happens exponent to an exponent? What law kicks in now? What's that? The fifth one, and you multiply the 2 and you go 2 to the 16. And in this particular example, you might be left with going, oh, that's way better. That's what I'm going to do. Maybe. Yeah, this one it does. But there might be other questions where it makes more sense to do it the other way. So you've got both options available. You're not stuck to bed mass anymore. You've got choices. The reason we were stuck to bed mass before is because we didn't have exponent laws available to us. So bed mass was the way to go. Now you've got a choice. You don't want to do bed mass, you're going to have to use your exponent laws. Okay? Questions about that one? 3 more to go. Your brain's blown up, okay? They're goodies though. Hey, if you're like, this is so easy, I'm so good at this, you might want to tune in for these 3. These are the ones that really get you ready for the riddle sheets. More time here? Choose whichever way you want. You can copy that one down. Okay. You hear my voice slowing down. I want to be careful on these last 3 examples and make sure I explain them very, very carefully. 4, x to the power 2, y, z to the power 5. What is it about this question that makes it that bed mass can't help me? All the variables in there, yeah. All 4 different bases. And so when they're all 4 different bases, bed mass can't do anything about the inside of the brackets. So you switch over and go, well, I can't do bed mass, but can I do exponent laws? What happens when you got an exponent outside a bracket like this? And I'm going to say it again. Which items inside the bracket get exponent 3 when you got an exponent 3 on the outside? All of them. Tried to say that a bunch of times this afternoon. So everything gets exponent 3. So 4 gets exponent 3. X squared gets exponent 3. I'm going to write an extra step that some of you may not want. Okay? So I'm going to write this extra step. Some of you are going to like it, some of you aren't going to like it. That means I got to go x squared, and that gets exponent 3. This is the way to write it if you're confused about what's going on. Just write each thing that's in the bracket and write it with exponent 3. Then y, it also gets exponent 3. And then z to the power of 5 gets exponent 3. Some people aren't going to like that step. They're going to want to jump, and that's fine in these. You can totally jump. 4 gets exponent 3, yes. And then x squared to the power of 3. There's my exponent law number 5. Multiply those 2 exponents. Z to the power of 5 to the power of 3. There's that exponent law of 5 again. Multiply those 2 exponents. And I get z to the 15. But some of you will want to go from here to here. That will make more sense to you. You'll like that better, just multiplying those exponents as you go. And that's totally fine. But I could go one more step here. This 4 to the power of 3 is a reasonable number. 4 times 4 times 4. And so if it's a nice reasonable number, we like writing that as just a coefficient, not with a power, for the number part of it. Not the exponent part, or the variable part of it, I can't do anything about. You see how that ties everything together? That's juggling 3 balls now. That's like, woo. And so if you're having trouble, and you're like, oh, I couldn't follow all that. I was doing good. Everything I understood up to there. And that's exactly how exponent laws go. It's at some point you're like, oh, there's one too many. And then you just practice some other questions for a while, come back to it, and you go, oh, I see how that all ties together now. We'll take a little time, but we do have all week to work our way through this. Questions on that one? More time? More time? 2 more to go. Oh, look at this one. Oh my goodness. See the movie Christmas Vacation, the Griswolds and everything like that? There's this moment where he turns on all the lights in his house, and all the lights in the whole neighborhood go dim. And then someone reaches and the big power company goes up and flips on 2 more bands of power, and all the power comes back on the whole thing. This example, if you've got that in your brain, the ability to turn on the power one more time today, this is the one. And a really good move, and I'm going to get a little help here. I'm going to put I'm going to build a square here, a little rectangle, and I want it to be, what color is that? Oh, that'll do. That'll do. I'm just going to change its size a little bit. This way a little bit. I think that's about the right size, and we'll see. Okay, and I'm going to make an extra one of them. So I got some squares here. Just to dramatize this, so you can really think about it when you're doing your homework. A question like this is completely intimidating because it looks like someone just puked out spaghettis all over the page. and you can't see everything that's going on. So use your thumbs or your eraser on the question and do stuff like this to it and go, okay, well, that's fine. I'm going to deal with that. And that's fine. I'm going to deal with that. But for now, I'm just going to let my brain focus on that. And then your brain calms down a little bit and stops stressing so much and goes, okay, just this part. Which things in the brackets get exponent 4 when there's an exponent 4 out there? All of them. I'm saying it so many times that you're almost like, yeah, we got it. They all get exponent 4. And if you're having trouble with them, write them all out individually. -2 gets exponent 4. X squared gets exponent 4. Y cubed gets exponent 4. Good. Now you're going to move your thumbs around on the page and go, okay, now I'm going to cover up this and this. Me, I'm going to move my square and just go, let my brain focus on this one for a little while. And here it comes again. I can't resist saying it over and over again. Which things in the bracket get exponent 3? All of them. And if you're having trouble with these, just write them out. Say, okay, 3 gets exponent 3. X to the power 4 gets exponent 3. Y gets exponent 3. Whew! But do you see how separating the pieces out allows you to just work on one? And look at this unbelievable line of math at the top now. But we just did it one piece at a time. And that's what we ended up with. Now you move your thumbs around on the page, and then you just look at this one. Does anyone know the question I'm going to ask? Trying to be completely predictable here. Which things in the bracket in the bottom get exponent 2 this time? All of them. 4 gets exponent 2. X gets exponent 2. And Y squared gets exponent 2. Some of you won't like writing that all out. It'll actually confuse you a little bit. You might want to do it like this. So this next line that I'm going to do, and deal with them each individually as you go and go, oh no, I'm going to multiply those. I'm going to get rid of my squares here now. I'm going to do those as I go. I don't need to write the extra line. That is x squared to the power 4, that's x to the 8. Y cubed to the power 4, that's y 12. So you're just going to want to handle all of those as you go, and that is totally allowed. To maybe jump right to here instead, if that fits with your brain a little more. If your brain's, no, I like to write them out individually, each one at a time, you're not really going to be any slower. It's just one extra line, really. Okay, to save you an extra line of work, let me show you the highlighter work here, as I'm going to go, okay, those can go together. And here comes the pink highlighter. And those can go together. So what I get is, let's see, -2 to the power 4, that's 16. 3 to the power 3, that's 27. x8 goes with the x12, that's x20. And y12 goes with the y3 is y15. I'm really worried about that step, that I've gone too fast. So I'm going to finish writing it out and let you stare at it for a minute and see what you think. And see if I've done too much on that step. We'll take a survey in a few seconds. Was it too much for one step? Give me something. It's okay. You can have extra steps if you want. You can have as many steps you want. I'm trying to just give you permission here at the end of the day here to say, there are ways to shorten this down a little bit if you really know what you're doing, right? So last line of this question, the 16s cancel. You can go 16 times 27 reduced if you want, but you're going to end up with 27. 16 times 27 divided by 27. Or sorry, 16 times 27 divided by 16. Those will cancel. So I get 27. Here it comes, 27. What exponent will be on x and what exponent will be on y? I'm really asking you to juggle a lot of stuff now and reach out and grab a different ball and use it here now. In the middle of all this, what happens here? Just subtract them. And here? Same thing, subtract. You see, that's actually familiar. It might be back in another part of your brain now. It's like, oh, in the middle of all this, I'm having trouble keeping track of them all. Yeah, absolutely. They're tough until they become so easy. It's like riding a bicycle, these questions. Like, so difficult, so impossible, and then all of a sudden it's like, oh, I got it now. Any questions about that one? Scary, that one. Toughest question we've done this year, I think. Lots going on. And we only started learning about it 2 hours ago. More time, though? Last one, it's not quite so bad. Which items in the bracket get exponent 5? All of them. So 3 gets exponent 5. X squared gets exponent 5. And y8 gets exponent 5. But some people won't like that. They'll want to jump. It'll make more sense in their brain to handle this as they go. 3 gets exponent 5. X squared gets exponent 5, and they're going to go right to x to the power of 10. And y8 gets power 5, they're going to go right to y40. And that's fine. So I say you can go here if that works better for your brain. You don't like it? Stick to this. This is probably the superior way to do it. But it doesn't work for everyone's brain. And then 3 to the power 5, decision to make. Is 3 to the power 5 too big to write down? 3 exponent 5, I get 243. No, there's no way that's too big. So I get 243 x10 over y40. One final question, and then I'll wrap it up. Why is it I can't subtract these two exponents here, this 10 and this 40? What is it about these questions that says you cannot subtract those two exponents? And if your brain's going, wait a minute, no, you can. You said if you divide, you subtract the exponents. You said that. I did say that. But I said one other thing. What's the important thing here, Ryder? Same base, x's and y's. Until we know what x and y are, that's as far as we can go with this. Okay? Final questions on this? More time? Okay, I've grabbed you 25 minutes here at the end.